All right, welcome to the third summer research video. We're going to construct elliptic triangle OAB, which means O is going to be a vertex. So we're going to use the center of the circle, center of the space as the vertex. So here's circle O, this is elliptic space. We made elliptic space. And I've chosen C, just out of thin air, to be the Euclidean center of an elliptic line that's going to go through these two antipodal points. You see them over here on the sides. See? I'm going to catch these two antipodal points. It looks like I'm pretty good. So here's an elliptic line. Let me emphasize it with a little bit of color. I brought colored markers today to show you how exciting math can be. So here's an elliptic line because it goes through antipodal points. And we're going to call this the point, I think that's going to be A. Yeah, that's the point A. And this guy here is the point B. So let me emphasize my triangle OAB. It's that guy. So we now have an elliptic triangle. I'd like to make its polar triangle, and the polar triangle is the triangle whose vertices are the poles of the sides of this triangle. So we have to get the pole of the side AB, or the side OA. Let's get the pole. So the pole of OA has to be on every line that is perpendicular to the line OA. Well, here's an elliptic line that's perpendicular to it. So we know the pole has to be on here somewhere. Let's see, is there any other elliptic line perpendicular to OA? And I see one. It's right here. The boundary circle, don't forget, is an elliptic line. So I have a right angle there. So that means that the pole that I'm looking for is on the boundary circle, and it's on this Euclidean diameter, which means the only place where it's on both, and we'll call that point up there, we'll call that X. This is the point X. X is the pole. Oops, you can't see it. X. X is the pole of OA. Now, by similar reasoning, this point over here, way over here to the side, this point W is the pole of OB. Now all we have to do is get the pole of AB. Well, the pole of AB requires some construction, which I've already done. This is the race to the pole. It's in the elliptic chapter. So let's see if we can get everything in the picture here. Come on, you stupid piece of paper. There we go. Yeah, I think I've got just about everything in the paper here. All right, so there's triangle OAB. It's in gray now. I have X and W like I did before. So we have the pole of OA is X, the pole of OB is W. Now we're trying to get the pole of AB. We did the race to the pole construction to find this P, this point P sub AB. So what I did was I have the center for the line, the elliptic line AB. So I'm doing something, you guys, I'm calling elliptic line AB as if it's a circle because it's a piece of circle, and a piece of circle has a center. So I start from C, I go to where the elliptic line hits the boundary, Euclidean segment there. Then I do the perpendicular to that Euclidean segment. And then I get this point right there, unlabeled. I put the point of my compass there. Put the point of my compass there. And I go through the antipodal point up here. Let me see if I can get that looking right for you. And it gives me this gray, this pencil line here that doesn't have really any purpose other than to find the point P. So that's how I find the point P. It's right there in the book. You got to be able to do that. Now the point PAB is the pole of AB. And now the goal for you is to make the polar triangle. So I need the triangle that goes through these 3 points. I need the triangle that goes through these 3 points. And you can see I've already made it for you. The elliptic line through WX is the outer circle. It's this little piece. And then I got to make the elliptic line that goes through X and P, the elliptic line that goes through W and P. And we have a great shortcut because we used these axes. There's a really nice shortcut because if I want an elliptic line that goes through PAB and X, well then if the elliptic line goes through X, it has to go through Z. So that means its center lies on this Euclidean line. So all I do is the perpendicular bisector in orange, and the perpendicular bisector of XP goes through and hits that horizontal, this diameter here. And I use that as a center and make this line. And the same thing over here. I want to make this thing. Well, I'm looking for somebody that goes through W. It goes through Y. So that means that the center I'm looking for is on this line somewhere. And I do the perpendicular bisector. You can see it here in this kind of like purple. And it comes up here and hits this point. And I make this line, this elliptic line. It goes through antipodals, W and Y. And now I've emphasized this triangle. And now the big point of all this stuff is, tell me the pole of WX, tell me the pole of WP, tell me the pole of XP. And you will see, if you do the thinking yourself, you'll see who's on what. And it turns out the pole of WX is O, the pole of WP is B, the pole of XP is A. In other words, the polar triangle of OAB is WXP. The polar triangle of WXP is triangle OAB. They are each other's polar triangle. Very important idea. So you guys get out your compass and straight edge, or use Geometry Sketchpad, or do both. Here is your homework to do. Start with, give yourself that quarter circle. This guy is a polar triangle. It's an elliptic triangle. Find its polar triangle. That's a trick problem, but if you think your way through it, it's easy. Number two, give yourself an obtuse angle there at O. So you again have an elliptic triangle here, using a big piece of the space. Find the polar triangle for this guy. And then number three is, do like what we just did, only give yourself an obtuse angle at O, and find the polar triangle for that. This should keep you busy. Use all your thinking, use all your constructions, and let me see if you're up with us, because this is where we are right now. It's only a few days in, and we're making triangles and polar triangles, because that's where the research is going to build off of. We got to be good with these animals. All right, stay tough, you guys.